Let's settle for this easy question today. It's basically two sum, but the only difference is the input array is sorted. Well, two sum initially, if you've done it before, it's linear time if you use a map, and linear in space as well. But because it's sorted, they probably want something better than that. I don't think you can do something better than linear time. But you could probably do something better with linear with the linear space. Maybe make it no extra space. To make it no extra space, there is one obvious way to deal with that, and it's to do with two-pointer approach. So taking the first one example. If I have two different things here, I put one at the end, and I take the sum of both. The sum of both is, well, 17, and the target is 9. 17 is definitely greater than 9. So I know that to decrease my answer, I would have to decrease the j pointer, because there's no way that 15 can be in the answer. I need the sum of two numbers. And if I want 15 to be in my answer, the closest I can get to 9 is to add it with the lowest number. But that's still greater than 9, so I know 15 can't be in the answer. Alright, that makes sense. And the same goes with 11. So 11 plus 2 is 9, so... no, it's not 9, it's 13, which is too big. And then that's the answer. And basically that's the idea of two-pointer. We can go through in linear time and figure out what the pair is. A sum that works. We just rule out numbers that definitely can't be in the answer. That's the idea. Until we get the pair that works. See if there's a better... Let's make the target equal to... let's make the target equal to 7 plus 11, so that's going to be 18. Here we have 2 plus 15. 2 plus 15 is 17. It's less than 18, so we have to increment I. Now 7 plus 15, that's greater than 18 as well, so let's... So the only way that I could modify these two pointers is to decrease j. So whenever I want to decrease my answer from whatever it is right now, 22, to something lower, I have to decrease the right pointer. And now I have the answer. Okay. So let's give that a go. I would have int I is equal to 0. We have int I and j. Let's do... let's make I is equal to 0 and... might as well declare it like this. Int j is equal to numbers.size minus 1. And do while I is less than j. Let's do I less than minus 1 because we guaranteed there to be an answer. And let's do if so the sum is equal to numbers I plus numbers j. And then we do if the sum is, here it doesn't really matter, we can say less than target then I want to increase I, so I want to go plus plus I, otherwise minus minus j. Oh, else if sum is greater than the target, do this. Else they're equal to each other, so break. And then return a vector of the ith, the one indexed numbers, so that will be just I plus 1 and j plus 1. Let's make this 18. Should be 2 and 3. And this one. Okay, hopefully that works. So the numbers, it's always worth checking the base case. Numbers is in between 2 and that. Okay. Minus 1000, decreasing order. One solution, yes. Let's submit that and see whether we got that right. Awesome, great. The thing is, I'm not using any extra space, but for some reason my solution is still using relatively a lot of memory, but it shouldn't matter too much.